All right, everyone, we're going to get started. My name's Tanya Zacco, and I'm the marketing manager here at Bala Consulting Engineers, and I'll be moderating today's webinar. Thank you for joining us for our AIA accredited webinar on COVID-19 and impacts to facilities. Our panelists today are from our Bala COVID-19 Task Force leadership team. And before we begin the presentation, I'm going to quickly introduce them. First, we have Andy Horning, who is Vice President and our COVID-19 Task Force leader. Scott Davis is Director of Mechanical Engineering and part of the COVID-19 Task Force research team. Chuck Kensky is Executive Vice President and also part of the COVID-19 Task Force research team. And lastly, we have Matthew Easel, who is our Director of Digital Planning and COVID-19 Technology leader. Just as a reminder that this presentation is worth 1 LU HSW credit. And when you registered, there was an area for you to provide your AIA membership number. If you did not provide that at the time of registration, you can send me an email at tmz@bala.com, or you can find my email in the registration email that you received. During the presentation, if you have any questions, you can use the Q&A feature at the bottom of your screen, and we will address them after the presentation is over with. Without further ado, I'm going to pass it along to Andy Horning to begin the presentation.
Thank you, Tanya. Welcome, everybody. Thank you for coming today. We're excited to have you here for our AIA presentation on COVID-19 and the impact to facilities. Next. We'll run through the typical AIA boilerplate slides up front here with regard to the course completion credits, et cetera. Next. Hopefully everyone's writing these down. Okay, next time. So just to lead us out here, I'll give you just a quick overview of what we're going to talk about today. As Tanya alluded to, we've had a group of about 35 people working across all 5 of our offices, Philly, New York, Boston, Baltimore, and DC, on COVID-19 since everyone's been sent home. We've put together a lot of information that's available at our website, such as a white paper, and we're going to give you a high-level view of our information today. As noted at the bottom, we do have additional information on our site for other market sectors, such as long-term care. We've done a lot of research in multifamily, K through 12, and higher ed. We're going to go through and talk about the virus today. We're going to give you recommendations on HVAC solutions, plumbing solutions, some electrical related solutions, technology solutions, and talk a little bit about workplace environment solutions. Now that will stray a little bit perhaps from the MEP side of things, but I think it's going to be part of a multifaceted, we're viewing this as being a multifaceted approach to getting people back into the workplace. It's going to involve both your expertise as well as ours, as well as as furniture vendors and even industrial hygienists. Next.
Okay. So before we get started, we definitely need to understand how the virus operates, how it may impact or influence our decisions going forward. So just a quick run through of the virus itself. It is relatively unknown as far as understanding or actual testing. So a lot of comparisons are made to the series of coronaviruses that this particular one is part of. As we know, this particular virus is SARS-CoV-2, and that leads to the disease which is called COVID-19. So again, a lot of comparisons are being made to the coronavirus as a group, and everyone's utilizing that as a backdrop to understand how this works. It spreads through human contact, touching surfaces, and as well as airborne water droplets, mainly coming from breathing and sneezing. The one thing to note about the virus itself, it has the propensity to attach to particulate in the airstream, such as dust particulate or water droplets. Current research indicates roughly about 80 to 90% of the virus will attach to it, which is helpful because we can then target those particulates, those water droplets, as far as strategies to remove it from the airstream. In addition, we've noticed that depending on the type of material, the longevity of the virus to remain active will vary. But also to note, this is changing, evolving every day. CDC recently published a paper indicating that their findings are now suggesting it doesn't last quite as long, or it's more importantly, it's harder to spread surface-to-surface contact. So it's something to keep in mind. We're obviously ourselves keeping up with that research. Next slide. So as I mentioned, it does spread through the air. The two main avenues of spread are people breathing, coughing, but also through fecal matter as far as bathrooms are associated. So they're going to be the two main avenues that this can spread, and these are going to lead to our main strategies. You know, we're going to target these particular items. Next slide. So the other thing to note and how this will impact how we address this in the workplace is we need to be cognizant of the higher risk population that have been identified, you know, such as noted here. So it's going to inform how we strategize, maybe setting up particular special areas, or maybe here you're going to consider shift work and or potentially staying at home longer. So again, it becomes an avenue of a strategy we need to address. In addition, precautionary steps listed here. Your most effective is going to be PPE, i.e. the wearing of masks. That will definitely help spread the potential getting into the air. As I mentioned earlier, one of the primary ones is through people sneezing or just even normal breathing. And one of the reasons why this is most important as an effective strategy is that knowledge that someone may be infected and it takes about 14 days to present itself. So even if you are successful in isolating your workspace, your area, you still have that potential penetration of that barrier with an infected person that doesn't understand or doesn't know it because they could be sick without presenting symptoms. So PPE is definitely going to play an important role in helping to minimize the spread. And as I mentioned, isolating areas, particular areas are helpful. And last but not least, the cleaning disinfection procedures that have been wide talked about are going to be an important role. Next slide.
So we'll talk about some of the HVAC solutions and our effective measures, what our research is bringing to us. So some of the things that we're going to talk about in more depth is increased filtration in the systems, the HVAC systems, bipolar ionization, the different types of UV light and what that can do within the ductwork in the unit in the room, implement pressurization control or enhance what you currently have so that we have positive and negative areas. We're bringing that from our lab experience. Increase outside air. So one of the things is going to be a good portion of this solution is it's true. Dilution is the solution to pollution. So bringing in more outside air is going to help flush out the spaces. And we're going to want to be able to do that at night, do purge sequences and stuff, where if you have a system that has a demand control ventilation, where it actually reduces the outside air based on the population, we want to deactivate that. We want to be able to keep the systems moving, air flushing the spaces out. We want to operate our exhaust systems 24/7. So typically your toilet rooms can shut off at night. By code, your janitor's closets cannot. So basically what we're saying is let's just keep everything running and pull everything through. We want to maintain a humidity level within the building. So what we're finding is the original research said that, you know, the virus basically becomes less active or deactivates between 40 to 60% RH. And what our new findings is determining is it's not less active, it's our bodies are easier and more able to defend ourselves against the virus when we're in moisture environments. And this has been proven out in many of the operating rooms where they have to be maintained with a humidity level to keep out viruses, disease, and infections. So this is new information that's just coming up every day. Now we get new stuff. We're going to be looking at sanitizing our ductwork with both aerosols and UV lighting. We'll talk about that. And then where you don't have, or you have certain types of systems that don't have central air, we'll be talking about portable air purifiers and ways to clean the air and increase your air changes per hour. Next slide. So here we're talking about filtration. So we want to increase the filtration in your air handling units as much as you can. Typically, you're going to have at most an MERV 13, and a MERV 13 is what you're doing basically for lead. We want to go a higher level of concentration or capture capacity than that. So if you look at the top, you've got these clouded areas that says virus on it, and we have the two red lines that go up and down. That's the size of the virus. But as Scott noted, 80% of the time, the virus is clinging to something, pollen, dust, smoke in the air, all different things, and it's becoming bigger and bigger, and it makes it easier to catch and capture. If you look at the bottom, you see this, the word HEPA and ALPA with a green line through it. That green line is like the sweet spot for the HEPA filter. But if you look to the left, you see it is capturing the pure virus itself. It's really going to do a good job on any of the viruses that have clinged or attached to other things. If you think, okay, well, I only have MERV 13s, is that good enough? Well, the MERV 13 really falls into the right of the word filter in the part where it says HEPA filter. So its ability to capture the smaller particles is not as good. What does this do? Well, the higher percentage of filtration allows us to capture more of the virus in our processes. And then the disadvantage is it's going to add more static pressure, which means we're going to need more fan horsepower, use more energy to actually run the systems. Next slide. Bipolar ionization. So this is one where you've heard of electrostatic precipitators. That basically takes the water and the oxygen and splits them and makes, oh, I forgot the word. It makes ozone, thank you. Ozone is an irritant. Well, we don't want that. So what we're doing, and we're looking at products that makes a bipolar ionization, which is putting positive and negative charges into the airstream and allowing the actual virus particles to adhere to them. It makes them heavier and they precipitate out. So this is actually different from the electrostatic precipitators. There's very, very little ozone that's generated here, which is an irritant. So bipolar ionization is something to consider where it actually puts these positive, negative charged particles into the airspace in the offices, in the environments, and helps to clean them. Next slide, please. UV light. So you have different types of UV. So what we're showing here is the UVC light, which is showing the light within the ductwork. So in order for it to be effective in deactivating the virus, and we try to say deactivating because it's not a living organism, we want to deactivate it from it being able to break down its RNA, its ability to replicate itself. And what you need to do is with the UVC light, you need to have an exposure limit. It's got to be exposed within 10 seconds or a duration of 10 seconds. And in order to do that, the lamps typically have to be 6 to 12 inches away from the actual virus for it to happen. You're looking at the lights actually deactivating the virus. Now, this is shown in a ductwork because UVC is not good for people. We'll talk about that in a couple of minutes. So you can put it in the units and you can put it in the ductwork. You don't want people looking at this, and we'll talk about it more. Photocatalytic oxidation, that's a good one to say. So up on the right-hand side of the screen, what you're seeing is a whole module that slides into the unit. And this is not technically a filtration unit. The green membrane does have a coating on it that helps oxidize and kill anything that may attach to it or deactivate it. It's kind of like hydrogen peroxide. You see it foaming. But behind that, you see the little white lines? Those are the actual UV lights. So the UV lights are actually going to basically deactivate anything that gets past that membrane. So that's another thing that we can be looking at to put into our systems. Next slide. So here's another one that they found. So far UVC light, it's a different wavelength. It's a shorter wavelength. So far UVC is safer for people. So you have UVC light, right? You have A, B, and C. A and B give you sunburn. C gives you cancer and cataracts. You do not want to be looking at it. You do not want to be exposed to it. So that's why it's going to be put into the ductwork or into the units or areas where it's not shining on people. The far UVC is safer for humans. It's got a shorter wavelength, so it can't penetrate the skin. You still have to be careful of looking directly at it because some of the far lamps aren't 100% far. They're like 89% far and 11% standard UVC. So you don't want to, unless you put the filters on the actual lamp, you got to be careful. And the lower quality ones tend to be less far wavelength. Something to consider. So they make LED lights that make UV light, and they have mercury lights, and then they have the krypton lights. So there's different types of making it, and the different types of lamp gives you a different strength. And the more strength, the more it's going to kill, okay? The faster it's going to kill. The far UVC doesn't contain mercury, it contains krypton. Next slide. Here's a shot or a picture of Singapore, where they're actually cleaning the buses. It could be Shanghai. Anyway, it's over in the east, where they're actually sterilizing or disinfecting the actual buses and trolleys and trains. So you can see they're pulling this bus through a tunnel. There's UV light underneath it, around it, and on top of it. And then the right-hand side, you can see they put the UV light on a cart and they're taking it down within the actual vehicle. So they're basically disinfecting it that way. Now, the one thing to remember, UV light is line of sight. It's not contact, it's line of sight. So if something is blocking it and causing a shadow from the UV light, where the shadow is, there's no cleaning, there's no disinfecting. So that's one thing to remember with UV light. In the hospitals and other areas, they take these carts like you see on the right, and they put it within a space for so many minutes, they move it to another spot, and they keep moving around the room to avoid making shadows. Next slide.
And just real quick, Chuck, they're also reporting now they're using that mobile card in the New York subway system.
Thank you. So some of the systems and solutions we just talked about, and you can see on the top here, we're going to talk about each one of those systems and what they can do, but how you apply them to the different type of mechanical systems in your building. So you can see with filtration, as long as we have a centralized system or we have a dedicated ventilation system, larger ones, we can increase the filtration. It's difficult to do it with a PTAC unit or some of the water source heat pumps and VRF systems. The UV light, it can pretty much be applied to almost all the systems, okay? As well as the bipolar ionization, whether that's in the main duct stream. And that's typically where we want to put it downstream of the fans. The portable air purifiers, you can put those in almost any place you need. And that is what Andy just talked about with the lights on the cart, as well as the filtration units where it's a HEPA filter and it's pulling additional air through, or they even have portable bipolar ionization units, which is putting the bipolar ionization into the room. So the humidification, we can typically do that where we have centralized air. And you can do that even in residential type buildings where we're putting in those smaller humidity systems or humidifiers into those systems. And outside air, we definitely want to do that. That is the low hanging fruit. You want to try to increase your outside air as soon as you can. Next slide.
Okay, so we took an opportunity to take a look at one of our projects and go through the energy impacts. So we took an office building. It's got a VAV, a typical VAV type air-based system. And we basically applied different techniques and then also looked at a combination of the different strategies. So what we see here is, starting from the left, that's our baseline as compared through the lead energy review process. And then the next one over is as designed. And in this particular case, you can see the numbers represent the lead points we got for increased energy optimization. So then we took a look at this in that range, that aspect as well. So just moving further to the right, we first looked at increasing filtration to HEPA filters. So you can see the slight increase due to the energy consumed there. And one thing to note too is this particular system was modeled with the air system turning off at night. So we're looking at normal occupied hours for about 12 hours a day and off on weekends. Moving further, we looked at the photocatalytic. You can see that's pretty much comparable to the HEPA filtration. These particular units don't have a heavy pressure drop, but they do have a power consumption. So we saw that coming into play. And as you can see, both of those, both the filter and the photocatalytic, dropped off our point values slightly. And the next one over is the humidity. We looked at increasing humidity. Basically, in this case, we added humidification. In this particular case, it was based solely on electric generation to steam. So you can see it had a toll on the overall savings and essentially reduced it to zero as far as a lead optimization point value. However, you can consider looking at other different technologies like adiabatic, ultrasonic type humidifiers that would bring this value down. Again, we wanted to kind of look at a worst case scenario. Moving further over is the application of UV. And here we looked at applying UV within the air handling unit system. And in this particular case, we looked at essentially installing it on the upstream side of the filters, and it would basically add as an additional way to sanitize any material virus particulate caught on the filters. You can see it had a slight uptick from the original as-built design condition. These don't actually draw a lot of power, have almost no pressure loss associated with them. So they're very advantageous as far as a means to protect the surface. The next one over is the photocatalytic. You can see that has a slight increase above. Earlier, we were looking at bipolarization. The photocatalytic had a little bit larger draw on it. And you can see it had a drop off in point value to 3. The next one is increased air, outside air. So here we model looking at outside air increase throughout the entire day. You can see it had a toll. In fact, it pretty much knocks us out. Under this scenario, we wouldn't even meet the baseline. And it would prevent us from actually applying for LEED certification. And last but not least, we took a combination look at adding in HEPA, humidification, and increasing outside air. And you can see that had a heavy toll. So the bottom line here is you want to be careful as you apply these. You want to definitely look at your energy impacts. If you're going for LEED, it will be an impact that you need to consider. Okay, next slide.
So some of the things you want to consider besides your high touch point areas, and this is one of them, the toilet rooms, is, you know, conference rooms, break rooms, stuff like that. Things you need to think about how we're going to address those and handle those. So for the plumbing solutions and plumbing and toilet rooms specifically, there are many, many, many different solutions. Boeing actually developed a toilet room for their plane that has UVC light in it. So when you leave, you flip the little switch, it gives it a zap of light for 10 to 20 seconds, and then it allows the room to be used for the next occupant. It'll say available. So similar along those lines, we could apply that to our toilet room. So you see to the right, you've got a toilet with a lid on it, and that little gray thing is actually a motion sensing UVC light. So they have them where it's under the lid. Most toilet rooms in our area don't have lids. So you're looking at this as, can I do this where I clip one on the bowl? And they do have them where they make them on the bowl. They're motion sensitive, so it will turn off if someone walks into the stall. But the key thing is they're saying, hey, if you can flush, per one of the earlier slides that Scott showed you with the moisture in the air, if you can close a lid and flush, that would be best. If you can't, you can do some sort of UV light, or you can do a spray and disinfect it within the bowl itself. So one of the key things we want to do in our areas is do hands-free fixtures as much as we can. Urinals, toilets, sinks, soap dispensers, make those hands-free. So we have less touch points. We don't have to worry about it. If you wanted to try the UV light like Boeing came up with, you could put it in the stall, but not above the stall, so it shines to the neighbor next to you, and maybe angle it down towards the toilet roll dispenser, and you could put it with a timer and an override switch and work it into the lamp. Or you could simply do what some people are doing is they're putting the UVC lights in the ceiling over the stalls and over the sinks, and they're only using them at night when the janitorial staff comes in. Lastly, we see that some people are saying, you know what, I can't be changing all my fixtures. I can't be putting all these lamps in. I'm going to hire a bathroom attendant. And this attendant can actually be in the bathroom. When you come out of the stall, he wipes it down, or, you know, wipes off the fixtures and stuff like that. And you go on your way. You bit your rest of your day. Next slide.
So we wanted to spend a little time talking about some technology strategies. And you'll notice that we're focusing a little bit more on strategies versus particular products. Right at the moment, there are a significant amount of products being developed. There's a lot of existing technologies that are being reutilized. And one of the things that we're seeing right now is that there's a lot of shifting in the market relative to new players coming in, a lot of technologies coming over from China that hadn't previously been deployed at scale in the United States. Most of the systems that you're seeing advertised these days, you know, the huge number of marketing materials and emails you're receiving about products each day, realistically, we're in the 60 to 90 day lead time for most systems, and that's growing constantly. Realistically, most technology deployments that you'd consider for new systems that you'd bring into your environment really are in a fall, or, you know, early fall or later fall for real deployment. But I think there the patience, exerting some patience can help us. Because a lot of these technologies, even the ones that are being repurposed, don't have that wide scale deployment. We don't have the experience of how they impact our users, the policies, and we haven't really seen this huge influx of manufacturers and providers start to pare themselves down to an elite number. So one of the things you'll see is that generally we're focusing on where we can apply strategies to existing systems, and then only backfilling when we don't have a capability now, or where there's a particular business case that or safety case that just demands it. In that same vein, we really want to be looking at the combination of both technology and policy together. The graphic that we have here of looking at multiple rings is specifically from our work on elevated body temperature screening using thermographic cameras. Taken alone, most of the technology applications will not mitigate the level of risk necessary for them to be useful standalone, but when combined with policies, let's say elevated body screening, for home testing, self-quarantine, with vacation or time off policies that incentivize users to self-report, then using versions of screening systems, thermographic screening, camera-based, IR-based, to help improve the number of people you're able to screen and bring in your facility. But then also knowing that there's a secondary screening policy in place that utilizes a human being to make that final decision. Combined together, that's layers that help protect your workplace that just the technology by itself won't do. At the same time, we also kind of want to understand how the risk profiles are changing. Most of the technology applications that are out there have benefits with a particular type of user. A lot of the technologies that we're seeing are actually more beneficial for multifamily, for long-term care and healthcare. And really understanding as we're deploying technologies, where we're trying to mitigate risk or where we're just deploying them for the sake of being able to collect information. There's a lot of systems out there, AI-based, that are looking to track users, to track whether people are wearing face masks, but without a real understanding of the policy implications and the impact to end users, especially in a workplace where they have the ability to go, many have the ability to go home. We need to understand whether or not the effort that we're putting into our workplace is worth the risk. Next part of that is we're really going to look at a focus on mobility, both inside and outside the workplace. It's safe to say that while some workers will come back, many won't. The heavy dependency that we have on our remote collaboration platforms, Zoom, Teams, whatever you're using right now, is going to be maintained at least through the early stages of coming back to the workplace. Ideally, those adoption levels will be maintained long term. But we need to understand what that's going to mean to our users when they're working at their desks. We know that people won't be using conference rooms as much. If you are able to prioritize a mobile use case, where you're focusing on being able to have all collaboration systems work with remote users, that will work back within the workplace. The inverse is not necessarily true. Technologies that focus on workplace only cannot be leveraged as well outside the workplace. I think there's some obvious touch use cases that we need to address. Obviously, even with the new CDC recommendations on or kind of reducing the concern about transmission through surfaces, we don't have information as to how that applies to specific surface types yet. And as there's more materials, antibacterial materials being developed, for the moment, a lot of our technology is touch-based. We've been focusing that over the years. So the areas where we can affect, existing security platforms, many of which can be updated to mobile credentialing, that allows us to use our phones, but most importantly allows us to enable wireless protocols for security keys passing back and forth versus touch, like with an RFID badge. We do want to disable touch on non-critical systems, things like a room scheduler, other touch surfaces where the need is not absolutely necessary right at this time. In conference spaces, most of our systems at this point, we can move to app-based. We can move to wireless screen sharing. We want to de-emphasize the use of controls, and I think you're going to see a lot of manufacturers coming out in the next few weeks and months, if they haven't already, with upgrades to existing platforms to allow them to continue being used. So those traditional AV touchscreen-based systems, we're expecting that that you'll be able to start implementing touchless control of those. One of the other things we want to look at is printing workflows, and this starts moving us into the conversation of sunsetting platforms that are underutilized. The last 8-10 weeks, however long that you've been doing work from home, hopefully has identified platforms that are underutilized or just have not been utilized at all during this time. And when you come back into the workplace, there really needs to be a discussion about whether or not you were able to work effectively, productively, can't say that right, while working remote. Do we need to be printing as much? Certainly there's going to be common touch points at printers. We also want to look at some other considerations. How many people have had a need for or have used their desk phone over the last 8 to 10 weeks? A lot of technology teams with our clients have been working over the last couple of years to move their staff and their users away from desk phones. This may be another great opportunity to use that, that push, that disruption that's come from remote working to reconsider whether you want to continue using them. We want to look for future resilience. Any platform that you're moving with forward needs to be able to address both a remote and an in-person work profile. We want to look at resilience over future proof. Future proof is putting as much power and effort in systems and equipment to hold the line for as long as possible, while resilience is acknowledging that things are going to change and really installing systems with the understanding that they will change over time. This also allows us to start looking towards some of our long-term planning efforts. If you were to look at a typical IT roadmap, moving systems away from on-premise, moving them to cloud, a lot of that was already planned for. Maybe it wasn't budgeted for yet. This is a good time to reconsider whether some of those decisions to keep systems on-premise or within your workplace are still important. We want to start focusing on tracking space, not users. Part of this is a user experience. Unlike healthcare or other industries where the users, the workers, and the people you're serving don't necessarily have the ability to go home, this is one opportunity where I think we're going to find our users are going to be voting based on where they're located. If we start deploying systems that are stigmatizing our users as if they were heavy security risks within the space, tracking where they are, whether they're wearing face masks, I think we're going to find that that's going to have a negative impact, and that's going to push our users back out. However, we can do things like reutilize existing occupancy sensing platforms to determine, was a space occupied that day? If it wasn't, let's not focus on cleaning it. Let's take our cleaning staff and push them somewhere where it's really more useful. We want to keep things simple. The more complicated at this point, the more likely a system is to fail. Whether it's a data tracking system, some version of contact tracing, which honestly we believe is better done at the state or federal level than at the individual business level. Those systems, once they break or when they aren't working as expected, your users will push back heavily. And many of these systems require some level of opt-in. Same way, we don't want to be using our user schedules to determine what space to clean, because the fact is most users don't accurately use room booking systems. And then long-term, and I hope the focus kind of showed up in this discussion, we really want to evaluate everything we're doing about whether it's helping improve the experience. I think we all know that that this face-to-face contact, which has been tiring for some people to be in these meetings like this, it has though improved the experience of meetings for remote workers, because we're all kind of democratized at that same level, that same quality of connection. When our users come back into the workplace, you're going to see a bit of a fracturing between the people that are remote and the people that are in place. And we really need to focus on how to improve that experience across the board. So there will be a lot of new products coming out. There will be a lot of specific systems that we're going to start recommending. But for the moment, focus on your existing environment, what you can leverage, what you can change most easily, and really look at how the decisions you're making now can be leveraged towards useful business in the future.
Okay, so we've talked about general MAP and technology practices. We wanted to take a step back and just kind of look at the overall general steps that people can take. Um, so we've been fortunate enough to work on a wide diversity of projects, including clean room and laboratory design. And there's some aspects of that that could be applied here. And one of the most obvious ones is, and we alluded to it earlier, about setting up a barrier, controlling your access. So we see the importance going forward at just controlling how people enter your space, people and materials for that matter. So it may be you're looking at restricting visitors, or you maybe take them through a separate point. But the key is going to be is to try and close down all multiple access points. Look to try and bring people in through one particular point. Now, obviously, you have to maintain your egress pass for code, life safety. So, you would maintain those as far as a way to exit the space, but we're really looking at ways to control and minimize entry points. Mentioning about materials, you might want to bring those in separate from people, so as to avoid any potential for cross-contamination. It also would give you the opportunity to wipe down packages, or opening them up in a controlled environment so that in case there is contamination, it doesn't spread. We've looked at the use of walk-off mats. Essentially, we understand from our research that a large percentage of particulate and virus, and I guess attached to that particulate, can actually come across on the soles of your feet. So a simple, very low tech, back to Matt's point earlier about the KISS method, keep it simple, very effective into protecting your workspace environment. We've also looked at different techniques as far as how you might sanitize your space, from a wipe down to a disinfecting a mist. And earlier we mentioned about UV. The trick here is to be able to get into the very obscure areas, places that are tough to clean, such as maybe a keyboard. So just something you want to think about when you're initiating your procedures. We talked earlier about pressurization control. Again, keep your communal spaces under negative pressure, such as conference rooms if you are going to utilize them, your toilet rooms, kitchens, again, if you're going to continue to utilize them in their current situation, or even on a limited basis. It's still a space that there's going to be an exchange of people. So again, just keeping under negative pressure is a good target. And then Matt, if you wouldn't mind to expand on the temperature.
Sure.
Mapping.
Yeah, we've done a lot of research on elevated body temperature systems, thermographic systems. There's a lot of names. I think 10 weeks ago, there was about 2 companies actively marketing systems in the United States. Now there's more than 50, of which most of them are relying on a couple base technologies that vary between individual screening and large group screening. I think the thing to keep in mind is that while the virus has a long incubation time where you can both be spreading it but not have symptoms, past work with temperature screening on SARS, H1N1, and Ebola has shown that it does help prevent the spread. And because of that, we do believe that temperature screening within a facility makes sense. When the number of people you're bringing into facility, the size of the facility, the speed at which they need to come in is just more than a single person can handle, or you have concerns about the safety of the people that are doing screening, there's a lot of really good systems out there now. I think what you may have found just even in the last 10 weeks, those systems have moved from being fairly bespoke and kind of pieces, parts that you have to set up, to being really just like the image that's here, much more compact and packaged for this use. We're expecting that to change. Lead times are still 60 to 90 days. Back to that idea of process, policy, and technology, this needs to be paired with the right methods of entering the building, with a secondary screening system, and in some cases it will take over your lobby to do it right. So it's one of those things you have to talk through and plan through, but it's definitely something that's worth considering.
So some of the workplace solutions that we're seeing and people are talking about are dedensifying the settings, spreading out the seating and the shifts so people are further away. So if you have a benching setup and people are elbow to elbow, you may need to put up screens between them, or you may need to separate them. Rethinking about how you're using conference rooms, maybe still do more virtual and take some of the chairs out and spread them out. If you see this in your shopping centers now, where you go up and down the aisles, it's one-way direction to avoid people crossing paths. PPE is going to be mandatory. We'll talk about that in a minute here, but eliminate points of congestions. Look at how you're going to constantly clean a touchdown point. So you mentioned about the day porter in the bathroom. You could have the same person also doing, or other people doing your touchdown areas, your conference rooms, your one-on-one rooms, anywhere where the people or break rooms are going to be congesting, always keeping things clean and wiped down. So when we talk about the PPE, we have gloves. You're going to have sanitizer wipes and stations putting at the doors in different high-use areas where you're getting your squirt of Purell. We see face masks being required for a long time. And the reason is, I mean, you can see this in China, they wear them all the time, but that's because their air's polluted. But we're going to be doing it to save people, right? So we want to do it to reduce the amount of virus that we're spreading via our moisture in our mouth. Sneezing, coughing, we're finding that the studies are showing standard conversations, you make a plume of vapor that comes out of your mouth, and that virus can sustain itself on that plume. So you could be sitting in your office and say, I got 4 walls and a door, I'm good. I can take my mask off, have my conversations. I don't need to do it. But you're making a plume within your room, and then somebody walks in your room, they just got potentially infected, because as Scott noted earlier, you may not know for 14 days that you even have it or that you're a carrier of it, or you could be asymptomatic. A large portion of the population is turning up to be asymptomatic, where they didn't even know they had it, but they have the antibodies. So you're not infected, but you're infecting others. That person could walk into the room, you can hand them a piece of paper and say, hey, can you type this up for me? Well, you just handed them an infected piece of paper. So we probably won't be seeing respirators, but we will be seeing face masks for a while. Some people may even want to continue to wear gloves. Next slide.
So as we mentioned throughout, cleaning is going to be an important part of this. You need to hit all surfaces. You're going to be looking at wiping down desks, workspaces. There are alternatives as well. As far as a disposable desk cover, say, that you could put down and then rip up every day, just to try to minimize and reduce the amount of cleaning you're doing. There's one thing we noted earlier too is, with all this heavy cleaning, you may have that desire now to flush out your systems, your spaces, meaning you're going to have a buildup of chemical smells just from the constant cleaning. So it would be advantageous to then run flush cycles. So you can temper that with this idea of, again, disposable work type surfaces, covers, whatnot, that will cut down on the amount of cleaning you need to do. Mentioned earlier about wiping all surfaces, packages. You're definitely going to concentrate on your communal spaces, restrooms, kitchenette type areas. They're obviously going to require heavier cleaning procedure throughout the day. And then as we mentioned earlier, the idea of sanitizing mister type applications and the fact that they have the ability to get into every little nook and cranny. So it's a lot easier to clean as opposed to continually wiping out every little surface and trying to get into those hard to reach spaces. Next slide. So we've now talked to all the different kind of strategies and whatnot. What we want to show here is this idea of short and long-term measures, because we understand that as we're all getting back into the workspace, there's going to be a lot of demand to quickly implement, but also implement some different technologies that might have problems with delivery times. From our research with manufacturers, we're noting that some of them are experiencing supply chain problems. It's just getting the raw materials so they can make the products that eventually want to ship out. So we see that it will be effective to have a host of different strategies, which we have been presenting, so that you have access to different technologies in case one maybe is just not working out for your particular setup, your environment, or maybe it's just because it's going to take too long to get on site. But again, there are certain short-term measures you can take, because we do advocate the idea of working with what you got first. And some of this, if you have a very robust BAS control system that you can access, you'll have a lot of opportunities in that respect. So some of the short-term measures, including adding in those flush cycles I just spoke of, where you can program them. And then what you do is, if you do have a limit on the amount of outside air that you can bring into your building, your area, you could look at ways to cycle that so that you bring in a certain amount and then you just move it from space to space to space. Essentially, you work with what your max capability is, and then you concentrate on specific areas throughout the day. So essentially, you're again working with what you have, but you're still giving the benefit of flushing out spaces. As we mentioned earlier about changing pressurization, if you have the capability, you can literally just change airflow settings and in a moment's notice change your pressurization. And we mentioned earlier about the use of portable equipment. Certainly getting portable equipment should be a lot easier to obtain at first, and it will provide you some level of protection. And just quickly on the long term, it's essentially what we've been presenting. These are the different strategies that you could apply across the board. So no need to go into it here, but we do look at those as long-term strategies because they will require modification of the existing systems. Chuck, I believe you had a thought.
I did. So I agree with you 100% that the short term is kind of like the low-hanging fruit. The long term requires an engineer to look at your system, to analyze what can be done, and for contractors to acquire the material and install it. That's why it's long term, not only to execute, but it's long term throughout the life of the building, if you will. So for example, in a UV light, you have to evaluate the ductwork to see if you can actually get, based on the air velocity, the duct size, and our 10-second exposure, if I can get enough lamps in that ductwork to make it effective. I may not be able to do that. I maybe have to locate the lamps at the coils to catch, to shine on what gets caught there, or at sound traps or turning vanes. So it's something that has to be studied. You can't just stick the lamps in there and expect it to work. For the humidification, you have to watch how the building's built. We don't want to be adding so much humidification to a building, because most don't have it now, where in the wintertime, we're causing moisture, condensation, we're causing issues with mold. We have too much when we have these really cold days. Fortunately, we get a week or two of really cold days, and we can dial it back with our control system, so we're not causing those issues. And then most of the time, we're in the 30s or 40s. We've got a good opportunity to increase our humidification. When you look at the filtration, again, you got to study the fans. You got to do all of these different things here to then determine what's going to be able to be deployed in your system. But what we see long-term is that the codes are going to evolve. We see that the ASHRAE is always at the lead. So ASHRAE's always done all the studies on the UV and the filtration and the humidification, everything that's going on, and we've been talking about. There's an ASHRAE paper on it. There's other studies and stuff. So ASHRAE is always at the lead of code. Code adopts ASHRAE, and they take 2 to 3 years for them to catch up. And then the municipality takes time after that. We see these changing the code. This is a pandemic that shut down the world. This isn't like the flu, where 60,000 people died from the flu in 2017, 2018. These are hundreds of thousands of people that are dying. This is so much worse. This shut down the world. So this is making all the code officials, all of the study agencies come back and say, we need to rethink this. We need to think of our buildings as long-term, healthier buildings. So we see the codes changing. We see LEED adopting to it, because these are going to require more energy. We see everything evolving over the next few years. Thank you, Scott.
One thing to add to that too, Chuck, especially specifically with LEED, I do see LEED trying to still continue to push the energy savings, sustainable design aspect of it. But one thing to note with a lot of these measures, they can be looked at as far as energy modeling and how you're submitting for LEED. They can be looked at as temporary measures. So you do have that ability to look at them as, I'm going to use them currently now for this particular pandemic, and if another one comes up in the future, you obviously have the arsenal at your fingertips. But taking it in the case here, there is that belief and understanding that once a vaccine is developed, it obviously will reduce a lot of the angst concerning this particular pandemic. And under that scenario, you may then, once your workforce is inoculated, you may be able to look at turning these things off. So I would throw that out there, that there is that aspect that you can have these on, maybe you're running for months at a time, even a year, but you could look at these technologies as a temporary measure in the sense of, looking at your long-term energy usage and therefore how it would impact on LEED. Now, along that line, I have to believe that LEED would consider something like this, and hopefully we'll adopt that as well, understanding that some of these may be temporary type measures. All right, next slide.
So as you've heard our whole team talk about, we've gone kind of deep down into the dirt on a lot of things. This slide is actually to pull back a little bit. One of the papers we have published is really from a sustainability angle. Ballot partners with Villanova University as part of their RISE program, which is Resilient Innovation and Sustainable Engineering. Through that, we were working with a group of research students, graduate level students at Villanova. We posed to them, okay, there's a lot of positives to bring everyone back in, but there's got to be some negatives too. So we had them look at this through a prism they use for sustainability called STEEP, which is based on social, technological, environmental, economic, and political positives and negatives. And we found that the students were able to very quickly get through this and put together the chart you see here. It was pretty interesting because it brought up the fact that, as Scott was just talking about, there's certainly energy efficiency we're going to lose because we're using more energy. But technologically, environmentally, we're getting cleaner buildings. We're getting healthier buildings. I won't go through all this. It was just kind of a chance to take a high-level view looking back and to look at the positives and negatives. Next. So as you see, this is certainly a multifaceted approach. It's not going to be just an architect, just an engineer. It's going to be a team effort requiring an architect, an engineer, a furniture guy, an industrial hygienist, or potentially a real estate guy, a project management firm, to make the improvements that are needed to bring everyone back to a healthier workplace that the workers are comfortable in. One of the things we've fought through this process has been the change in research, the number of things day by day. The CDC just issued information 2 nights ago. We're kept keeping up on all of that. And we've been kind of trying to make sure we're keeping our papers live so that we're keeping up with the latest information. As Chuck was just talking about, the future mechanical system strategies are going to change because they're going to become part of the code. And we can see that coming. As it says, we know that we're all coming back to a new workplace. It's certainly not going to be the place we left 10 weeks ago. And people are going to have to work in a different manner. The next steps are working with our clients to get to that stage where we're bringing those people back. As the parts of the country are starting to come open. Suzanne, do we have any questions from the Q&A we'd like to go over?
All right. Yes. Thanks, gentlemen. We have a couple questions. First one, the ionization process inherently produces ozone, correct? And which product are you looking at specifically, and has it been tested for the amount of ozone being produced?
Scott, you want to take that one?
Sure. So starting with the manufacturer, we've been looking at Atmos Air. They provided a lot of, they probably provide the strongest language as far as testing. As we talked about earlier, there's nothing specific for this particular coronavirus, but they have looked at other viruses and the breadth of coronaviruses that have been to date, such as the SARS and the Middle East one. Now, that goes to its effectiveness. Now, Atmos Air in particular promotes that they do not produce ozone. As Chuck alluded to earlier, ozone is more associated with the typical negative ion electronic precipitators out there. So we are staying away from those particular. We're looking at this bipolar technology. And to date, we've got a couple manufacturers now that seem to be able to produce it, and we're looking into them further just to make sure that they match up.
Okay, next question. How do you ensure the UVC attains 10-second exposure on the passing air in ductwork?
So that's a math equation. You have the duct size and the air volume, and you have a velocity. So you have to be able to determine what is the length of lighting array that I need based on that velocity to give me a 10-second exposure within 6 to 12 inches of the lamp. So you're doing a math equation is what that is. And like I said earlier, you may not have enough straight lengths of duct to do that. So you may have to look at areas of concentration, which is coils and turning vanes and sound attenuator, stuff like that.
And just to add to that, put a little frame of reference on that. We've looked at that recently on a particular project, and we're looking at about 1,000 feet per minute. That translated to about 167 feet of ductwork. So you're talking about a very long length of ductwork with an interlaced structure of UV lamps to get that 6-inch exposure limit. So it can be very daunting to apply that in the airstream.
Next question, are there any studies proving UV being able to deactivate airborne viruses in a moving airstream? What were the test parameters?
So ASHRAE is the leader on that. And if you look at any one of the ASHRAE white papers, they make a specific one for long-term care, hospital care, where they call it an in-room UV light system. And they have all kinds of white papers on this where the actual UV light is up on the wall. It has a louvered system that keeps the light from shining down on the patients. And the key here is that it's constantly shining across the ceiling. And the way the air patterns are in the room, it's basically deactivating whatever shows up there. The further the distance, the longer their exposure time. But if you want to get into specifics, you really need to read the ASHRAE papers on that.
Can you define the difference between sanitize and disinfect?
So sanitize is typically considered by the CDC as a gentler cleaning, okay? But you're lowering the number of germs or bad things that are on the surface. Where disinfecting is killing 100% of it. So it's more stringent. So one is getting rid of some of them, and you still see it when you put the light on it, if you will, you see in the commercials, versus I'm wiping it out, it's gone.
Okay. And Matt, here's a question for you. Can you elaborate on what you're seeing people do for thermal screening?
Yeah, so for the moment, early on, there was very little thermal screening happening. There's a lot of people attempting to purchase. Most of the clients that we're talking to, most of the people that are interested are currently still demoing systems. What I can tell you is that as the packages went from independent camera, display, stands, and have now started to focus themselves on prepackaged, easy to deploy, either just plug it in the wall or PoE, we're seeing that the deployment is starting more less in the workplace to start, where the impact of identifying safe is not quite as understood and it is not as vital yet. It's definitely happening in service industry, restaurants, especially systems that have the ability to look at thermal screening of the staff and then actually array that into a digital signage display that shows you the staff that are going to be waiting on you today and that they've all been shown to be tested, within a acceptable temperature range. So you're probably going to start seeing these systems show up more in your day-to-day out shopping, and then you'll see them in the workplace more. Just the limited availability has made it very difficult right now to see them show up at really scale anywhere. But lots of orders are being placed, that's for sure.
Thanks, Matt. Next question. How do you see the codes adapting?
So I briefly talked about that on the long-term, short-term. We see the codes changing to require more of these systems to be built into new projects, new buildings, so that we have healthier buildings. And one of the comments is that these things are going to draw more energy. And is there a benefit of a better, more healthier, safer room versus the trade-off for the energy consumption? Well, unless LEED changes their rules, LEED is really geared towards operational cost, not energy savings. So if you remember back when LEED was first starting, if I can reduce my operational cost, I am getting more points. So I could do a chilled water ice storage system at night, which uses more energy, but I'm peak shaving during the day. And that was a big thing that everybody did until the peak charges from the utility companies got knocked out, and they made it less viable from that perspective. So these strategies will end up being part of the code, is what we're seeing.
If a UV system is installed in the ceiling of a workspace, how long does it need to be on at night to effectively disinfect all the desk surfaces?
That's a direct factor of the strength of the bulb, the type of bulb you're using, the distance from the surface. It depends on the lamp you use.
And also, just add to that too, is if any shadows are created. So you would definitely have to look at layout so that you do not have any dark corners. 'Cause obviously, it doesn't work if it's not in the surface.
Okay, and last question. If I'm designing a new building, what items should I incorporate into my design?
I think you want to look at, we definitely have the low-hanging fruit. You want to look at the increased airflow, ventilation airflow. You want to look at increased filtration. Then you start to look at what do I want to do with my humidification. You look at them based on that chart that Scott provided with the energy and the compare that with installation costs and start to whittle it down from there and work your way up. I like to think of it as an ice cream cone. I've got chocolate, vanilla, and strawberry, and I like all those different flavors. The more I add, the more I like. The same thing applies here. These are supplemental to each other. So one is no silver bullet. All of them together do additional levels of safety in the building. Not call it safety, but cleaning and disinfecting, if you will, in the building. So if you can do all of them, it's great, but you can't always do all of them. You have to evaluate it based on energy and costs.
Another way to view it too is it could be tantamount to a programming exercise. In some respects, it's aligning the owner's goals with the potential strategy. So, for example, if you are going to pursue LEED, then you may be leaning towards more the lower energy consuming type avenues or strategies. You know, and again, as we mentioned, our idea here was to present options, a multitude of different strategies, so that you can pick and choose as needed. And then, as Chuck mentioned, in the end, each of these strategies are a way to reduce the probability or potential of spreading the virus. So essentially, it's how you pile on is really back to your comfort level. So it definitely becomes establishing the criteria first, and then that will help inform the decision to what strategies you might go after.
We actually had 2 more questions come in. Is there a role in UVC light-based device that can be used to disinfect classrooms?
Yes, this is the one that we mentioned in the hospital where they actually bring it in and they put it in an area for a certain bit, move it around and move it around, and you do it like that. There are roll-in models, all different kinds. There's one called the Torch. There's actually the robot that does it on itself. There are a number of different roll-in UV light models available.
Okay, here's another question. My question is on the energy analysis for more outside air. Understood that the additional costs are significant for traditional VAV RTU systems taking on more outside air. What about retrofitting for DOAS, energy recovery, and repurposing ductwork? And for new construction, designing for DOAS as a must?
So with the outside air content, I guess as far as a DOAS system, that would really depend on how much air you're bringing in. Essentially, going back to the idea of first looking at it as a flush out strategy, essentially the more outside air you bring in, the quicker you can flush out of space. So depending on your timing that you're looking at, again, going back to your chemical use, if it's heavy, you're obviously going to want to utilize more fresh air. But again, it'll be tied to when you clean. So if you're going to clean throughout the day and you're starting to notice a buildup of smells, then you're going to want to apply that more frequently. And under that scenario, maybe you do want to increase your outside air. But if you look at maybe an overnight flush out, you're going to have a lot more opportunity to increase your airflow without impacting maybe the current heating and cooling capability of the unit. Especially at night, you almost always have a setback anyway on the temperature. So if you give yourself a certain amount of setback on temperature and relative humidity while you're flushing, that will again give you the opportunity to increase outside air content, without going too far overboard or having to cause yourself a lot of cost and space needed for bigger ductwork and whatnot.
So to add to Scott's concept though, if you're retrofitting and your ductwork's already fixed within the risers and the shafts, you're going to be looking at your fans and your fan horsepower and being able to increase those. So, you know, we're not talking about a large increase. You could be 20 or so % of your airflow is coming from the DOAS, and you may be increasing it another 10% or so. We see that you've got the ability with the controls to ramp these up as you need to seasonally. So as we mentioned, that your body has the ability to fight off any diseases and COVIDs and the flu and everything when there's a higher moisture content. So if you're not able to do a lot of humidification, you might want to increase your ventilation at that period of time and ramp it off at the periods of time where you can do more ventilation, and key it in on flush cycles. So there's going to be a lot more chemicals used within the space for disinfecting. You want to be able to flush that out, whether it's at night or different parts of the day.
All right, well, that wraps up our presentation for today. Thank you everyone for attending. And again, if you have any questions after this presentation, please feel free to email any one of the guys and they will be more than happy to answer them for you. Thanks again for attending and have a great day.